On page 125, let's talk about higher order derivatives. It says, just as you can obtain a velocity function by differentiating a position function, you can obtain an acceleration function by differentiating a velocity function. Another way of looking at this is that you can obtain an acceleration function by differentiating a position function twice. And we've talked about this before, how acceleration is the rate of change of velocity, so acceleration is the derivative of the velocity. So you could think of it as either taking, to get acceleration, taking the derivative of the velocity, or think of it as taking the derivative of the position function twice. And that's the way I want you to think of it right now. So the second derivative of a function is the derivative of the first derivative. So now we got to, when we say derivative, we mean first derivative. Okay? But now we're going to have second derivatives, third derivatives, fourth derivatives, 12th derivatives. Okay? So a function has, you can take as many derivatives as you want. Okay? So look at the different notations. For the first derivative, we're used to y prime, f prime of x, dy dx. Every now and then I'll even throw this at you, derivative with respect to x of, and then it's usually I throw a single term at you, f of x. We almost never use that. Second derivative, y double prime, f double prime of x. And then this crazy thing here for second derivative, there's a reason it's written that way, as usual with things like this. I don't remember the reason, but there is a reason. And then this one makes sense, I think, to put the second on there, and that one makes more or less sense. Then you got y triple prime, f triple prime of x. That means third derivative, that means third derivative, that means third derivative. Then once you get to the fourth derivative and higher, you don't just keep putting primes. You put the number of derivative you're talking about in a parentheses. So that doesn't mean y to the fourth. Since the 4 is in a parentheses, that means the fourth derivative of y. The fourth derivative of f of x. The fourth derivative, fourth derivative, fourth derivative. So in general, the nth derivative would be y with, in parentheses, an n up there. So that's the nth derivative of y, the nth derivative of f of x, and so forth. Make sense? All right. Let's take a look at a couple of examples before I give you your assignment. So this, let's see, number 82 is on page 127. It says use the graphs of f and g. Let p of x equal f of x times g of x, and q of x equal f of x divided by g of x. We're going to do part A together. Part B will be part of your homework. So part A, they want us to find p prime of 4. So p is the product of f and g. So if I want to find the derivative of p, I should use the product rule. So look, watch what I'm going to do here, because this seems like it's going to be really, really complicated, and it's actually not. So p of x equals f of x times g of x. How do I know? Because they told me that p of x equals f of x times g of x. Now, I can find p prime of x using the product rule. The product rule says that the derivative of a product is the first function times the derivative of the second plus the second function times the derivative of the first. So p prime of x equals the first function, f of x, times the derivative of the second, g prime of x, plus the second function, g of x, times the derivative of the first, f prime of x. Close your eyes. Open them. All right, so P prime of 4 means to find the value of P prime when x equals 4. So if we're finding the value of the derivative when x equals 4 instead of f of x, wouldn't that be f of 4? And can't we make g prime of x g prime of 4? And g of x is going to become g of 4, and f prime of x becomes. So again, it keeps seeming like it ought to be complicated. And has it been complicated so far? No, it's just that you might not have thought of doing it this way, but this is actually kind of simple so far. Okay? Everybody with me? All right. Now, close your eyes again. You can open them. All right. F of 4. Well, you see the graph of f, and f of 4, there's the point on f when x equals 4. So what's f of 4? Not 8 like I said. 1. All right. Then we got to find g prime of 4. Now, they don't give us the graph of g prime. They give us the graph of g. But look right here. That's the point on g where x equals 4. Well, the derivative is the slope of the tangent line. So, if I drew a tangent line, let's get rid of that one. If I drew a tangent line to that red point up there, wouldn't it be horizontal? And what's the slope of that tangent line? 0. So what's g prime of 4 equal? 0. Yeah, I wrote mine backwards for some odd reason when I did this. Plus, so I've got 1 times 0. I know what that's going to be. Plus, all right, then g of 4. Well, what is g of 4? It's 8, right? The value of g when x equals 4 is 8. And then times f prime of 4. Well, back to this one. Now, we don't want the value of f. What's the slope? Remember how this works? The slope of the line, when a function is linear, the slope of that line is the derivative. So what's the slope right there? It's 1/2. So I've got 1 times 0 plus 8 times 1/2. And the final answer is? So I like problems like this because this is one of these, do you understand what you're doing or not kind of problems. It's not one where you're going to mess it up because you leave off a negative sign somewhere. You're not going to mess it up because you can't do the algebra to rewrite your answer. It's, do you understand how the product rule works? That's how you get that. And then, do you understand what these symbols stand for? Do you know that f of x means the value of f when x, well, that f of 4 means the value of f when x equals 4? You do. You know that. The part that you might not is, do you know that g prime of x means the value of the derivative of g when x equals 4? Okay? And then they don't tell you what it is. You got to figure out, okay, there's the point where x equals 4. G prime, that'd be the derivative. Derivative means slope. So I need to know the slope of the line at that point. If you can work your way through that kind of reasoning, then the problems like this aren't so bad. In fact, problems like this can be kind of easy if you're able to work your way through that kind of reasoning. Okay? So, any questions on 82A?
Well, now
Yeah, you'd think, but look what they do to you. Yeah, they change the x. See ya? Because right here, where the point is with the x equals 4, that part's linear. So the graph, or the slope of the line is the derivative. Okay? So I just, I went up 1 over 2. All right, we good? Number 105. All right, let's see. We've got to turn over to page 128 for this one. They say, use the given information to find f prime of 2. And then they do give us a lot of information. G of 2 equals 3, and G prime of 2 equals negative 2. H of 2 equals negative 1, and H prime of 2 equals 4. And f of x equals 2 times G of x plus H of x. So f of x equals 2 times G of x plus H of x. If we're supposed to find, f prime of 2, first we need to find f prime of x, don't we? So like we did back on 82, we're going to do it with just the symbols. We don't actually have to work out, a calculation and simplify with all the stuff that we usually end up having to do. So f prime of x equals, well then to take the derivative of 2g of x, use the constant multiple rule. It'll be 2 times whatever the derivative of g of x is. And what can we call the derivative of g of x? G prime of x, the derivative of g of x. Plus, and then what can we call the derivative of h of x? H prime of x. Now, f prime of 2 means replaced all the x's with 2's. So f prime of 2 equals 2 times g prime of 2 plus h prime of 2. And hopefully they've given us all of this information. Let's see if they have. So we have 2, and then they tell us that g prime of 2 equals negative 2. So replace g prime of 2 with negative 2. Plus, and then we need h prime of 2. Well, they told us what h prime of 2 is. It's 4. So replace h prime of 2 with 4. Oh, so that's a negative 4 plus 4, and the final answer is 0. No, it seems like it's going to be, but it's not. So that means that this function f, which is defined this way, that the derivative of f when x equals 2 is 0. Mm-hmm. Yep. Yep. When you take the second derivative, third derivative, whatever, just keep doing the same rules. And see, it sounds horrible, right? But sometimes derivatives get easier as you go. I mean, watch this. If y equals x cubed, what's y prime equal? 3x squared. What's y double prime equal? 6x. What's y triple prime equal? What's the fourth derivative of y equal? What's the fifth derivative of y equal? What's the 94th derivative of y equal? 0. Okay. Follow me? Now, could it go the other way and just get to the point eventually where you just want to throw your hands up and say, I'm willing to miss that one? Yeah, I mean, sometimes our answers are really horrible looking, right? So taking the seventh derivative of something that's using the product rule and the quotient rule to start with could be kind of nasty.
I'll just take a -1.
Yeah.
So if you keep on taking derivatives enough times, will all answers eventually equal 0?
No, because not all answers, if it's not a polynomial, it's not. Watch this. What's the derivative of the sine of x? Cosine of x. What's the derivative of the cosine of x?
Negative sine of x.
So now what's the derivative of negative sine of x?
Negative cosine of x.
So what's the fourth derivative?
Sine of x.
And reciprocal.
Isn't that going to get annoying?
Yeah.
No? Hey, here's the thing. If you can figure it out through one cycle, you got, in theory, couldn't we then figure out what the 76th derivative is?
Who wants to try?
Yeah.
It's sine of x. It's sine of x.
Yeah. It's the sine of x. All right. Let's see. Hang on a second. Let's do number 112 together. Says the graph of f is shown. Sketch the graphs of f prime and f double prime.
All right, let's do it.
It's sort of scary, yeah. All right. You don't have to write this part down. Here's what you have to think, though. Start at the far left of the graph and go to where something seems to be happening to f, which would be right about -4, wouldn't it? What's the graph of f doing? Well, that's not a good way to say it. Let's think of it this way. For all real numbers, what's the graph of f doing? Increasing, decreasing, can't tell, what? It's increasing, isn't it? If a function is increasing, its derivative will be what? Positive or negative? Be positive. So, to graph f prime will always be positive. Okay? Now, right here, what's f doing right there? It's going horizontally for some little brief moment in time, right? So what's the derivative of a function if the graph is going horizontally? 0. So I know that the derivative is always positive, and I know that it needs to equal 0 right there where the red is. What's a way to make it positive but equal 0 right there? Doesn't do it, right? I'm not saying at this point that's the only way it could look, but that satisfies it, doesn't it? All right, so that's f prime. Now, ignore f and look at f prime. F prime is decreasing from -infinity to -4. F prime is decreasing. If a function is decreasing, what's the sign of its derivative? So f double prime has to be negative until it gets to -4. Then again, looking at f prime, right there at -4, what should its derivative equal? 0, because it looks like there'd be a horizontal tangent line at x equals -4. And then f prime's increasing again. So then what would f double prime be? Positive or negative? Positive. So it needs to be negative to the left of -4, 0 at -4, and positive to the right of -4. Does that do it?
Oh, yeah.
That does it. Now, could it be squiggly and have curves and all this stuff instead of being a line? First glance, yes. Okay? But you know what probably is going on? F, the black graph, is probably a cubic function, isn't it? Doesn't that look like a cubic function? Guess what the derivative of a cubic function is? A quadratic, isn't it? See how that works? If you've got x cubed, what would that be? X cubed plus 4, or would it be x minus? Which does it and shifts it over to the 4 left? I always forget. And if I multiply all that out, I get, so in other words, I got x cubed, blah, 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 right? Well, take the derivative of something x cubed. Don't you get something x squared? So it'll be a quadratic. Take the derivative of something x squared, you get something x. So what I think is happening is that we have a cubic whose derivative is quadratic, whose derivative is linear. Am I positive that's what's happening? No, I'm not. I'm not. But that's a pretty good chance that's what's going on, isn't it? Okay? All right. And that will be the last assignment from section 2-3. So 79, 81. Oh, I forgot to put 82B. Do 82B. 93 through 117, 129 through 134. Here's number 35 from page 126. Let's see, what are the directions telling us to do here? Just find the derivative of the algebraic function. And look at the way I did it. I did not try to use the product rule. In theory, the product rule works for as many different products as you want. You just do one derivative at a time. So you could do like that function times that one times the derivative of that one, plus the first one times the third one times the derivative of the second, and all that. But there's going to be so much multiplication that you're better off just sucking up and doing the multiplication. So I multiplied the x minus 5 times the x plus 1 to get a trinomial. Then I multiplied that binomial times the trinomial. Then I combined some like terms. And once I finally get to there, the calculus step's easy. So that's the way I tackled number 35. Do what, if it doesn't tell you what rule to use, you just do whatever seems the best to you. All right, what else? 61. All right, here's 61. This time the directions say to evaluate the derivative of the function at the given point. So we have h of t equals the secant of t over t, and then the point they give us is pi negative 1 over pi. Well, before we can worry about evaluating the derivative, we have to have the derivative. So, quotient rule. So h prime of t equals the bottom, t, times the derivative of the top, and the derivative of the secant of t is the secant of t times the tangent of t, minus the top, so minus the secant of t, times the derivative of the bottom. Well, what's the derivative of t? What's the derivative of x? 1, so what's the derivative of t? So times 1, right, over the bottom squared. And at this point, there's really not much you can do with that. We don't really need the parentheses around the secant t, tangent t. So you could just leave them off and call it a day. Or what I'd rather you do is factor out a greatest common factor of the secant of t. So I factor out the secant of t. So when I divide what's in front of the minus sign by the secant of t, I'll get t times the tangent of t. And then when I divide what's behind the minus sign by the secant of t, I just get a 1, so negative 1. And then even that didn't help a lot, did it? That's about as good as I can get that answer. All right, so then we're supposed to evaluate this derivative for the point pi negative 1 over pi. So we put in pi for t. So notice the secant of, instead of writing the secant of pi, I wrote 1 over the cosine of pi, because that I can look up. So 1 over the cosine of pi. Then in the parentheses, replace the first t with pi, replace the second t with pi. In the denominator, replace that t with pi. All right, then the cosine of pi is negative 1. So 1 over negative 1 gives me negative 1. The tangent of pi is 0, so that becomes pi times 0. Well, pi times 0 is 0, so what I have then is negative 1 times negative 1. So I get positive 1, and then that pi squared in the bottom never went away. So 1 over pi squared. All right. Something else you're dying to see? 75. Let's see, what do the directions for 75 say? Determine the points at which the graph of the function has a horizontal tangent line. All right, so we've talked about these before. Horizontal tangent lines have a slope of 0. When the slope of the tangent line is 0, that means the derivative equals 0. So we need to find the derivative and then set it equal to 0. So f of x equals 4 over x, or 4x minus 2 over x squared. So let's quotient rule it. F prime of x then is going to equal the bottom, x squared, times the derivative of the top. The derivative of 4x minus 2 is 4, minus the top, 4x minus 2, times the derivative of the bottom. Derivative of x squared is 2x, over the bottom squared. So x squared squared. With me on the first step? All right, well, x squared times 4 is 4x squared. And then I need to distribute a negative, and I need to distribute a 2x. So let's distribute a negative 2x. So negative 2x times 4x is negative 8x squared. And negative 2x times negative 2 is positive 4x. In the denominator, x squared squared is x to the 4th. Well, I've got some like terms I can combine in the numerator. 4x squared minus 8x squared is negative 4x squared. That's all I did on that step. Then I can factor that. I can factor out a greatest common factor of 4x. Remember, when you're factoring a greatest common factor, you actually use the smallest exponents. So I can factor out a negative 4 or a positive 4. I chose negative. And just an x to the 1. Use the smallest exponent. So if I divide negative 4x squared by negative 4x, I'm left with x. And then if I divide 4x by negative 4x, I get negative 1. And this does help because I have a factor of x in the numerator and a factor of x to the 4th in the denominator, so I can divide those out. No more x as a factor in the numerator, make that an x cubed in the denominator. So factoring did help, and that gives me this as my final derivative. Any questions on coming up with the derivative? Uh-huh. All right. If we'd have got 0 up here, that would mean the derivative always equals 0, which would mean that at every point there was a horizontal tangent line. All right? So if that would happen, we would have said that x equals any real number or all real numbers. Okay? But if we get this for our derivative, and we talked about this the other day, when does a fraction equal 0? When the numerator equals 0. So don't set the denominator equal to 0. The denominator has nothing to do with when a fraction equals 0. So if you take negative 4 times x minus 1 and set it equal to 0, you quickly get x minus 1 equals 0. So x equals 1. And the directions did say find the point. So don't stop at x equals 1. Take that 1 back up to the original function. Substitute 1 in for x. So that'd be 4 minus 2 over 1. Well, 4 minus 2 is 2. 2 over 1 is 2. Mm-hmm. All right, we got time for one more if you want it. Yeah. All right, how about 15? That looks hard. So 15 says to find f prime of x and f prime of c. F of x equals x squared minus 4 over x minus 3, and c equals 1. So they tell us that c equals 1. We didn't make that up. They told us that. All right, so before we can find f prime of c, we have to find f prime of x. So the first thing, and the thing that's going to take most of the time, is finding the derivative. Use the quotient rule, so f prime of x equals the bottom, x minus 3, times the derivative of the top. The derivative of x squared minus 4 is 2x, minus the top, x squared minus 4, times the derivative of the bottom. The derivative of x is 1, so the derivative of x minus 3 is 1, over the bottom squared. So that binomial squared. Then we work on simplifying it. So you distribute the 2x times the x minus 3, and then you distribute a negative 1 times the x squared minus 4. That gets us there. Then we combine like terms. And so here's my final answer for f prime of x. Okay? You with me? Now, f prime of c. So that means the value of the derivative when x equals, well, whatever c equals. So since they told us c equals 1, f prime of c will be f prime of 1. All you do, just like if you had f of 1, all you would do is replace every x with a 1. Well, if you have f prime of 1, you replace every x with a 1. It's just that it's the derivative you're working with, not the original f. So f prime of 1 just means use the derivative, which you have right above you, and replace every x with 1. So I replace that with a 1, that with a 1, and that with a 1. So I get 1 squared, which is 1. I get negative 6 times 1, which is negative 6. Copy down the plus 4. In the denominator, that's 1 minus 3, quantity squared. Well, let's see. Our numerator then, 1 plus 4 is 5. Negative 6 plus 5 is negative 1. And then our denominator, 1 minus 3 is negative 2. Square the negative 2, we get 4, so it should be negative 1/4. And I just had positive 1/4. that help?
Yeah. So just apply. So, f of c, or the UTC, is the same as that.
No. This is an f of x. What is that? That's f prime of x. So f prime of 1, you go to f prime and put in 1s. Asking you to find f prime of c is the exact same thing as saying find the value of the derivative when x equals 1. Since they told us c equals 1. So finding f prime of c, which is f prime of 1, is the same thing as saying what's the value of the derivative when x equals 1. Alrighty.